Welcome back to the 10th video about my dual engine control lever IP68 project. In the last video we machined these two POM blocks to their major dimensions, and these will form the side pieces here of the whole contraption. Card here, link in the description. Now it's time to make some holes into these things. Enjoy! Just a short recap about what we are going to do. We already talked about the detailed drawing in the previous video. We need to make some holes here into the things, and this is two holes here, or maybe one hole going through. That is, we will drill here at the small side for the spring mechanism to go in. Then we have, of course, here that big center hole, which will contain the shaft where the levers will be attached to. Oh, this way around. Attached to in the end. And we need two more holes here also on that face to attach the whole thing at the end to the center part. And so it's time again to leave our mark on the work pieces. So that first line will be 11 millimeters. That's the one center line for the large hole and the holes in the side. So we really have to mark that only on the large face and the sides. The next lines are the 10 millimeters here off the ground for the side holes. The side holes are not completely symmetric here on that side. They are on one side 10 millimeters away, the center is 10 millimeters away, and on the other side 13 millimeters. Then two lines, 8 millimeter from each edge for the screws that hold everything together. And these screws come in at a height of 21 millimeters. And the last line should be a center line through the piece for the large hole at 50 millimeters. And if I really worked exactly, if we turn that around, that should be the same line here. We'll have a look at that in a second. By the way, I think it was in the first video about the levers, card here, link in the description, when I explained how I like to set up that thing to a certain measurement. Anyway, the whole process leaves some burrs here on the material, so they are really going outwards. You can feel them, but they are really easy to remove with the fingernail. You can clean that up, and that gives you some debris. At least it did on the other piece, which I didn't film. Yeah, you just scratch it until it's, yeah, you can see some black particles here, until it's really clean. And you see that the two marks on that piece here of the center line, they are a wee bit off, just a wee bit. On the other piece, yeah, I did the second piece off camera. It looks really good. Yeah. It's time to drill now. So I put the chuck on my spindle and the piece into the vise. Please note that I used my short, so 10, not short, but only 10 millimeter parallels here to put the piece in. Not that it's really necessary, but you simply have a better control if the piece is really sitting down here and not, at an angle when both parallels are really, tightly fit in here. I also added here at the side a little piece of PCB because fortunately I noticed we are basically with our first holes 11 millimeters in here. One of the holes is 12 millimeters, so 11 minus 6 is 5 millimeters left, and these parallels are 4 millimeters wide. That was a little bit too less margin for my taste, and I really didn't want to drill into the parallels, so I put here I think it's 1.6 millimeter PCB in here to get a little bit more room for the big 12 millimeter drill. You already saw me how I visually align my center drill on the markings in the also the first video on the aluminum levers. Already carded a link in the description, so I won't show that again. Just be sure I'm really trying to align it to the best of my abilities, and that's a little test dot directly on the line. Let's center drill that first hole, shall we? And now let's go for the 6 millimeters. Now, these are some quite interesting chips. I will now drill the hole on the other side. I guess I only give you a slow-mo of the 6 millimeter drill biting into the material. We're now at the center 12 millimeter hole. I already aligned my center drill, and I think I give you a slow motion of the center drill now. The largest drill I was able to fiddle in here was a 5 millimeter, not a 6 millimeter, but it will do for now. To fit my large 12 millimeter drill in here, I would have to lift up the whole assembly about 8 centimeters, and then you will see that in a second. That's important. I couldn't reach with my small 5 millimeter drill back into the hole. So we make a step in between and first lift the whole thing up by 6 centimeters so I can fit in that 9 millimeter drill. I moved the whole head assembly higher so I can now fit in that 9 millimeter drill, hopefully. Should work. But at the same time, I'm also able to still move that 5 millimeter drill I used to drill that hole down to the workpiece. So I can now use the 5 millimeter drill and the already drilled hole to realign my workpiece because, since I moved the head, everything is out of alignment. The whole thing is just a tedious process of moving the compound until my already got it here. Sorry, until the drill drops into the hole without any scratching and any force. And now we can, with a hopefully perfectly aligned 9 millimeter drill, widen the hole to 9 millimeters. Now I will repeat that game so I get the 12mm drill in. I've moved the head up and aligned everything again with the previous 9mm drill. And now I guess I give you a slow-mo in between from the 12mm, because this will be a long and tedious process to get that hole through now. My workpiece is now sitting here on the small face on the very bottom of the vise. I'm not using any parallels here because, yeah, the standout is big enough as it is. No need to erase it another 10mm. Anyway, my 5mm drill should just reach into the hole. So we will do these side holes in 2 goes from one side, and then I turn it around from the other side. Otherwise, it's exactly the same game. Aligning optically my center drill and then drilling. Only 1 go. No adjustment of the head necessary this time. Everything is aligned now. So first a bit of center drilling. And now we're going down with the 5mm into our big hole. And now I will do exactly the same from the other side. Maybe I give you 1 or 2 slow-mos. And those were the last 2 holes, or the last hole. Anyway, I finished the other block off camera exactly the same way. Maybe it went a little bit faster because I was able to optimize some operations, but look how much material we got out of these 2 blocks just by drilling a few holes. And so the last operation for today commences. Cutting an M6 thread here into the side holes. I disabled the return spring in my drill mill. It's in drill mode now. So the head here is pressing down with the weight of the spindle. So I don't have too much work to do, but for turning the thread cutter here. Okay, yeah, that was the first hole. I will do 3 more off camera. It's totally possible that I will need to buy other tools to extend these threads further down. It completely depends on yeah, what springs I can get here for the friction mechanism. That's it for today. I successfully stuffed here all 8 holes. Well, not all 8 holes, but 8 of 10 holes. I mean, that's a nice result. Precision-wise, I think I need another tool to cut the threads even deeper into the material. That depends how the spring mechanism works out, and maybe I have to widen these holes to 6.5 or 7 millimeters, because this is a little bit of a tight fit for a bolt. But otherwise, they turned out fine. So next time we will fill this hole, or at least we will make a part to fill this hole, that is the shaft. Till then, bye.